says, name the interval with the greatest average rate of change. In math, the words average rate of change simply mean slope. So again, average rate of change is a fancy way of saying slope. So what you wanted to do was look at that graph and identify which of those three lines had the greatest slope. So from point -6 to 2, that is going up 2 and over 4. So that had a slope of 1/2. From -2 to 0, it went up 4 and over 2, so it had a slope of 2. And from 4 to 5, it went down 5 and over 5, so that had a slope of -1. So our greatest slope is that +2, therefore the interval was -2 to 0. Factor completely. So the coefficient in front of r squared is 1. So you are simply looking for two numbers that multiply to 50 and add to 15. So you would set that up as r and r. Both insides are positive, therefore both factors are positive. And the two numbers that multiply to 50 and add to 15 are 10 and 5. In the second one, your coefficient in front again is x. So you have 1, so therefore x and x. The last number is negative, the middle number is negative. Therefore, one factor is positive and one is negative. And you need two numbers that multiply to 36 and add to -5. So that is going to be a -9 and a +4. And then it says solve and plot your answer on the number line. So when you are solving, you're getting x's on one side and all of the numerical pieces on the other. So we're going to subtract 1/3 from 4. So it's going to leave you with 3 2/3. If you were to write that as an improper, then that's 11/3. And then you're going to subtract over the 1 with the x on the other side. So we move that 1 away from our x's. So you get 11/3 equals 9. Multiply by our reciprocal. And we get 27/11ths. 11 goes into 27, 2.5-ish times. So you would plot your point in there somewhere. It's like 2.455. So again, 4.5 around 5. Write the equation of a line in slope intercept. That's y equals mx plus b. So again, gave you that little like handy dandy sheet. Slope intercept is going to be y equals mx plus b. So if you have a slope of -2/3 and a y-intercept of 7, you get y equals -2/3 x plus 7. We've recently been re-simplifying radicals. Anytime you have an even radical with a negative, your answer is non-real. So that square root of -16 would give us 4i. 50 would break into 25 and 2. So you get 5i, square roots of 2. The square root of -1 would also be I. And then you would have I to the 551. So remember, the rule is that if you have I to a power, you take that power and divide it by 4. see where you fall into the cycle. So a remainder of 3 means that I to the 551 is really equal to I cubed, and I cubed is really equal to negative I. The sum of a complex number, a plus bi, and its conjugate is a real number. So remember, the conjugate means that it is its opposite imaginary. So if you add a plus bi to a minus bi, the plus and minus bi's will cancel. A plus a would give you 2a. A is the real, bi is the imaginary. So that will always be a real number. That will always be a real number. Solve the following. So again, we have 2 quadratics. Not all quadratics are factorable. So if it is not factorable, you would need to do the quadratic formula. In order to solve any quadratic, the first thing you need to do is set that equal to 0. You cannot square root both sides just because x squared is isolated. You got an x sitting on that 6. So you've got to get all the variables and all the numbers to one side. So I'm adding that 6x, subtracting that 27, and saying, oh, well, that is factorable because x and x get me x squared. 9 and 3 get me to 27. And because it is negative, 1 is positive, 1 is negative. My 9 is positive because my 6 is positive. But this time it asks me to go one step further. It asks me to solve. So again, this is factored form. Solving, I get negative 9 and positive 3. Number 2 is already in factored form. Number 2, however, is not factorable. There are no factors of 8 that sum to 5. Factors of 8 are 1 and 8. That's 1. So it's going to give you 7 or 9. And 2 and 4. So those are going to give you 6 or 2. So now we go to our fallback, which is quadratic formula. So negative b plus or minus the square root of b squared minus 4ac all over 2a. So you get negative 5 plus or minus the square root of 25 minus 32. So it's going to give you a negative 7. And we know that if we have a negative, we bring it out as an I. Same ideas and concepts in numbers 1 and 2 in the last problem. So we have quadratics. We need to get them in standard form set equal to 0. In number 1, you could simplify that and take out a 2 because everything is divisible by 2. And we get 6. Factors of 6 are 2 and 3 and 1 and 6, none of which get you to 4. So in number 1, we are going to have to quad form that. Again, you can take the quadratic formula of the part with the GCF out. So I can look at negative 4 plus or minus the square root of 16 minus 4 times 1 times negative 6 all over 2a. two negatives, we'll turn that to a positive. 16 plus 24 would give me 40. So then I would take out the square root of 4, which would be 2, leaving behind a 10. And if it were multiple choice, more than likely it would simplify the 4 divided by 2 to negative 2, the 2 divided by 2 to a 1. Remember, you have to simplify it away from both numbers, not just one. And then number 2, same idea. There are no factors of 10 that will sum to negative 5. So we quad formula. You cannot simplify the 15 and the 10 because one is in a square root and one is not. So your final answer would be 5 plus or minus I square roots of 15 all over 10.